For this problem, we're going to use the distance formula and simplify our answer, typing an exact answer using radicals as needed. So first off, I have here the distance formula, and the next thing I want to do is substitute in these values for x sub 1 and x sub 2, y sub 1 and y sub 2, given the values that I see here. After I make this substitution, I'll then follow the order of operations. So the first thing I'll do here is evaluate what's inside each set of parentheses. And 4 minus negative 3 is 4. And 3 minus 1 is 2. Next, I'll square each of these. So I get 16 and 4. And then I add these together and I get the square root of 20. But as you can see, that is not the final correct answer because the square root of 20 has to be further simplified. To do this process, I recommend coming to the side and think of the factors of 20 such that at least one of those factors is a perfect square. In other words, numbers like 4, 9, 16, 25, so forth and so on. Those are perfect squares. And 4 times 5 are two factors that would describe 20, that equals 20, and at the same time 4 is a perfect square. So I'm going to make that substitution here. So instead of writing the square root of 20, I'll write the square root of 4 times the square root of 5. I'll then use those properties of exponents or radicals, however you want to think of that there, and separate them as square root of 4 times the square root of 5. And then note that the square root of 4 is something that we can calculate. Because 4 is a perfect square, the square root of 4 is 2. And that's how I arrive at this answer, 2 square root of 5. Again, just as another note, I cannot take the square root of 5 any further because 5 is not a perfect square and it doesn't have any other factors that are perfect squares. If I were to type any of this into my calculator, I'm going to get a decimal approximation, but again, my math lab is asking for the exact answer using radicals. And so that's why we can stop here at 2 square root 5.